Welcome to another Voltlog. Today we'll be taking a look at what I've been receiving in the mail recently. As much as you guys like watching this stuff, I also like getting all these electronic modules from China. I find it interesting every time I get my hands on a new circuit. First item for today is one that you already know and have seen in previous videos. It's the linear adjustable bench power supply kit. I have built a power supply complete with enclosure using one of these kits, so if you haven't seen that video, I will link it on screen right now. I got a new kit because I have an idea. I might be building a multi-instrument into one bigger enclosure, like a power supply plus dummy load integrated inside the single enclosure. But I'm not exactly sure, it's just an idea, so far nothing conclusive. Anyway, I ordered the power supply kit to have it ready when I decide to start working on the project. And we can see they are now shipping a resistor color code table with the kit, which is nice. Many of you probably already know the details of this kit. It uses a schematic that has been circulating on the internet for many years. It only works with AC input because it has to generate a negative rail, so you can't just buy a laptop power brick and build this power supply kit. You will need an AC supply, like coming from a transformer. It has a limitation with the supplied components. If you're going over 30 volts or even at 30 volts, it's approaching the maximum voltage limit of the op-amps used in this schematic. Anyway, all of this is discussed on a very long forum thread over at electronicslab.com. Our next item is also power supply related. It's a small 7812 linear regulator kit, and I got this one just to have it around for those cases when you need a clean low current 12 volt rail. I say clean because this is a linear regulator, so it will have a pretty clean output. And I say low current because if you pull too much current, this thing with this very small heatsink will get very hot. So if I'm building, for example, the linear power supply kit showed earlier, and I have a 30 volts DC rail, I can use this regulator to generate a 12 volt rail for powering something else like the front panel meter or a small fan. So a pretty handy kit to have, and you can replace the 7812 they supplied with any regulator in the 78 series, and I would probably replace it anyway with something from a good known source like TI, ST, onsemi, all the other good manufacturers, because the chip they supplied might be of the one hung low grade. Also, you might want to replace the capacitor, the electrolytic capacitors, with something more reliable. Next up, still in the power supply section, we have this buck boost module. They claim some interesting stuff in the product description on eBay. First, they claim it has higher efficiency and it's stronger than the XL 6009. And we like strong chips, don't we? We don't work with any weak chips. I'm not sure what chip they're using in here. In fact, let me try removing this heatsink and see if we can read the chip numbers. You might be hearing some background noise, but there's nothing I can do about that. It's springtime here, and outside they're spraying insecticide with one of those blower style machines, so it's quite noisy. But anyway, I managed to read the numbers of this little guy right here, which is controlling the show on this module, and it's the FP5139. And yeah, it's made by a Chinese company. I think it's called Filling Technology, which is, yeah, great name for a semiconductor company. They claim this module can do 3 amps without any special cooling. I'm guessing, well, with this supplied small heatsink, and 4 amps with forced cooling, which might imply a cooling fan. and that is not bad at all for this small module if it is real information. They also have another line in the description which gives 30 watts for natural cooling and 60 watts for forced cooling. And that might be unrealistic, but considering the price, which is under $4 with free shipping, you might want to give this one a try yourself and see if it will work for 4 amps continuously with this small heatsink. If I ever get to use it in a project, I will test it before and see how it behaves. Well, apart from the one hung low capacitors, there is nothing really to say about, nothing bad to say about this module. So a link will be provided in the description below. Next up, still in the power supply section, we're staying here for a while, and I have this boost module. This module is a step-up DC to DC converter rated for 2 amps based on the MT3608, which is an integrated DC to DC controller in a small SOT236 package, and the IC is made by a company called Aerosemi. Aerosemi, to me at least, looks and sounds like a good name, at least when compared to the other names we see coming from China. The module itself is made by icstation.com, but maybe you'll find it under different names as well. It takes 2 to 24 volts input and can output 5 to 28 volts. I had a project in mind where I was using some ultrasonic transducers, and I thought about using something like this boost converter just to get a higher voltage on the transducer for a higher power output. But these could also be used for a variety of other things, so they're good to keep in the lab. That's why I got 3 of them, and if you're interested in this, there will be a link in the description below the video. Next up, we have an interesting but disappointing module at the same time. It's a buck step-down synchronous regulator. A synchronous regulator, when compared to a standard buck, uses a second MOSFET instead of the diode, thus eliminating the losses associated with the voltage drop on the diode. And if we look closer, we can see we have 2 MOSFETs on this module. This one takes 9 to 35 volts input and has a fixed 5 volts output capable of 5 amps. I'm not sure if that's with or without extra cooling. The device does have plenty, the module does have plenty of copper on this PCB. It might be enough cooling for 5 amps, but I'm not sure. It uses the TP40057 from Texas Instruments, is this guy right here. So a nice controller chip made by a good manufacturer. The inductor looks very good. It looks like it could handle 5 amps. It has thick wires inside. Everything looks nice until we take a look at the input section right here. And I have to give credit to Julian Illett because I think I saw this module on his channel a while back. I don't remember exactly when, but I remember he noticed the issue as well. We have what looks like a reverse polarity diode on the input of this module. Having this diode in series with the positive input means all the current flows through the diode and we get a voltage drop. The same voltage drop we were trying to eliminate by using a second MOSFET in a synchronous topology. So I don't get it. To me it looks like this is as efficient as a standard buck converter with a diode. But that could be easily fixed by removing this diode and installing a jumper link in here. You will lose the reverse polarity protection, but you will regain back the efficiency. So if you're interested in this module, there will be a link in the description below. Next, I have this lithium battery charging module. This one can actually charge 2S packs because it's based on the TP5100. The chip is made by the same company that makes the TP4056. It's called Top Power ASIC Corporation, and I will link the datasheet in the description below because it is kind of hard to find it through Google. This chip is not a linear charging chip though as the TP4056, but it is a switch mode IC and we can immediately spot the inductor on the board. Being a switch mode chip, it means it can have higher efficiency, which results in higher specs. For example, the input voltage can go up to 18 volts and the output current up to 2 amps. By the way, the datasheet is all in Chinese, but I was able to translate a few things for you guys using Google Translate. So the switching frequency is 400 kilohertz and it has some nice protection features like overcurrent, under voltage, over temperature, short circuit and reverse battery protection. For selecting between 4.2 or 8.4 volts, meaning 1S or 2S packs, you get this jumper right here. It looks like it's an 0805 or maybe 0603 SMD package jumper. And by default it ships with this jumper open, which is setting for 4.2 volts. Closing the jumper, you get 8.4 volts for charging 2S packs. It has a small built-in dual color LED on the board, but they also send you this through-hole dual color LED. A pretty nice and cheap solution for charging 2S packs. I was searching for something like this lately, and now that I found it, I definitely recommend you get yourself a couple of these. The link will be in the description. I'm sure you will find a good use for these. Also got myself 4 of these ICR 18650-26F lithium batteries. These are made by Samsung and they should be 2600 milliamp hours in capacity, and I have tested them with my dummy load and indeed they have that capacity of 2600 milliamp hours, so these are genuine batteries. I'm planning on using these on a future project, maybe in a battery powered Bluetooth speaker. Not sure, we'll see about that in a future video. I also got myself one of these Wemos boards. I saw these on Andre's channel in one of his videos, and Wemos is basically an ESP8266, but they standardized the on the size and shape so you can get various shields and connect them together. So this module pretty much has everything you need to get started in working on the ESP8266. And you can see shields come in this shape. I ordered a couple of different ones, but they haven't arrived yet. It's just these proto shields that have arrived. These will be used in a future project I'm working on, which connects to the internet to read some data, but I won't give you any details on that because it's supposed to be a secret until it's been made public. I'm also thinking to collaborate with other channels on that project, but we'll see how that project works out. Next, I have this small audio amplifier module. It's 2 times 15 watts class D. It's based on the TPA 3110 chip from Texas Instruments, and you've seen this particular chip before when I built the Bluetooth amplifier box. I will place a link in the upper right side of the screen to that video if you haven't watched it. I plan to build a custom Bluetooth speaker enclosure. So far I have the 2 speakers, I have some Bluetooth modules to choose from, I have the MDF sheet that I'm going to use for making the box, and now I have the amplifier as well. So I'll probably start working on that project soon. This thing takes 8 to 24 volts input, so I will probably need a 3S lithium battery pack to power this, because I don't want to introduce any switching regulator, for example like a boost regulator. That might affect the sound quality. I don't want to do that. I want the amplifier module to be powered straight from the battery. or if I don't go with the 3S battery pack in this amplifier, I might choose another amplifier that will work with a lower voltage. Maybe it will have lower output power. I don't know exactly, I need to do some tests, but this module was really cheap, under $2 with free shipping. Check the video description below for a link to this module. I won't spend too much time discussing the next item. It's a DigiSpark development board. It's probably the third time you've seen this item on my channel. It's basically a tiny 85 development board. It can do USB, so it's versatile, small and cheap. From time to time I use one of these to do simple jobs inside projects. I find these useful, so I always like to keep a spare one in my toolbox. Next, I have a gesture sensor module. It's based on the APDS 9960, which is an AC capable of proximity, ambient light, RGB and gesture sensing. It's incredible the amount of sensing that happens inside this very tiny package, which is like 4 by 2 millimeters. In terms of communication, it uses an I2C interface, and it does have an interrupt engine capable of generating interrupts when it senses something. When it comes to gesture sensing, it has 4 IR diodes capable of sensing up, down, left, right movement. And I think based on these 4 individual values, you can probably identify many different gestures using some software processing. I'm not sure it has any pre-programmed gestures that it can sense inside and give you an interrupt or an alert for those when it detects those, or if you have to do all the processing external. Either way, it's kind of a cool chip. It's not necessarily new technology. It's been around for years in smartphones like the Samsung Galaxy series, but the technology has probably matured and it's now more widely accessible. I just thought it's a very interesting sensor, and it would be nice to have it around if I ever decide to experiment and use something like this in a project. It's also inexpensive. I paid under $3 for this module with free shipping. As always, a link will be in the description below. And our last item in today's video is this PWM generator module. It can generate 2 independent PWM channels with adjustable duty cycle up to 150 kHz. The step size changes with the range because it does have 3 ranges, 1 to 999 Hz, 0.1 kHz to 99.9 kHz, and 1 kHz to 150 kHz, which overlaps the previous range, but this might be misspelled info from the eBay description page. By default, it outputs at 5 volts because well, you apply power, for example, through this micro USB connector at 5 volts, so it's only logical that it will be powered. It will have a 5 volts output. Let me just supply power and see how this looks when it's powered on. In fact, you have seen this module before in another video of mine, the one where I tested the portable oscilloscope from Proto Labs, but I didn't tell you much about this module back then. So as I was saying, by default it outputs a 5 volt signal because that is what it gets in, but I believe it can be adjusted by supplying an external voltage, because I see some pads on the back. I'm not sure if those are outputs or inputs to the board, but there is something mentioned on the product description page that it can output. It can be the output can be adjusted for different level. Another interesting feature is the serial interface, which is accessible right here, and the fact that you can control the parameters over serial. You just have to send a simple string containing the channel, because it has 2 channels, the frequency and the duty cycle, and you adjust the parameters over serial. I think a module like this does have some utility, but I find just the interface with these buttons and the 7-segment display to be ugly. It just isn't really easily adjustable. you have to remember all these weird interface quirks. Unless you're using this module more often, you're probably going to forget how to adjust this thing. You're better off adjusting it over serial. That's easier. But even with this downside, so far out of the cheap PWM modules that I've taken a look at, this one seems to be the best. As always, I appreciate feedback and discussions in the comment section below. Please let me know what you think of the items and of the video. And don't forget to hit the like button. That is always a clear indication of what kind of content you guys like seeing. So I will see you next time.